Hello student, today we start the unit number 5. The name of the unit, cost estimation of the machined part. Means we create the lots of part on the various machine like a lathe machine, like a milling machine, like a shaping machine, like a drilling machine. So here we calculate the cost of that part. Today topic is cost terminology associated with the machine shop. Objective of the today lecture, terminology associated with the machine shop. Second, the cutting speed is dependent upon the following factor, means the cutting speed are dependent on the which factors. And the third objective is estimate the labor time, because from the labor time we calculate the cost of labor. We start the terminology associated with the machine shop. First is the cutting speed. Cutting speed can be defined as the speed at which the cutting edge passes over the material. It is expressed in meter per minute. The cutting speed S is equal to pi dn by 100 meter per minute, but where d is equal to centimeter. If the d in mm, then the cutting speed S is equal to pi dn by 1000, where d is equal to job diameter in centimeter, n is equal to job revolution per minute, means rpm, and S is equal to cutting speed meter per minute. The cutting speed dependent upon the various factors. Let's we learn. The cutting speed is dependent upon the following factor. The first is the machinability of the machine. Less cutting speed is kept for the hard job. The second is the material of tool. We can keep higher cutting speed with the high speed steel in the comparison to the carbon steel tool. Cutting speed can still be increased if carbide tool is used. The third one is depth of cut and feed. For less depth of cut and feed, we can keep higher cutting speed. Less cutting speed is adapted when depth of cut and feed are more. Next one is the cutting fluid. Higher cutting speed can be kept when the cutting fluid is used. Different cutting speed, higher cutting speed can be kept when the cutting fluid is used. So this 4 terminology we used for the cutting speed. In the industry, there are set of cutting speed table already present with the different types of material and with the different types of machine. Let's we see the some of example. If we use the aluminum material and we perform our operation as a threading operation, then the cutting speed is required 30 meter per minute. If the cast iron we use and on the milling machine, the then cutting speed required 50 meter per minute. Like this set of material, set of cutting speed, and the setup for the setup machine, the one sheet already present at the industry. The second terminology is the depth of cut. It is the difference between the radius of the bar before and after taking the cut. In other words, it is the amount by which a tool or the cutter is inserted into the metal during one cut. It is also called the thickness of the metal removed in one cut. It is generally measured in mm, where d is equal to initial diameter, the small d is equal to diameter after the cut, then the depth of cut is equal to d minus d upon 2. The next terminology is feed. It is the feed of work or tool. It is the distance that the tool travel along the work or work travel along the tool for each revolution of the work or tool. Feed is generally expressed in mm per revolution. No specific value for feed can be mentioned as it is dependent on the depth of cut and the cutting speed and the power of the machine. The L is equal to length of cut in centimeter, N is equal to RPM, T is equal to time in minute. So feed F is equal to L upon NT mm per revolution. The next terminology is approach. Approach is the distance over which the cutter must be engaged before the full depth of cut is reached. Before starting the cut, the tool is placed somewhat away from the starting point. Let's see with the figure. The tool is away from the starting point. This is the starting point and tool center point this. So this distance away from the starting point. Therefore, tool traveling initially some distance. See, the tool travel from to this point. Initially some distance before full depth of cut start. In case of the lathe machine, during the travel of approach distance, tool is not in the contact of the job. It is denoted with the letter A. Overrun. After completing the cut, the tool loses the contact of the job, and after losing the job, contact tool is traveling some more distance. This distance is called over travel or the overrun. Let's we see on the figure. So this is the job. This is the final cut, the final distance, and tool travel some more distance. Tool travel some more distance. At this time, tool travel this distance. Okay. So this distance denoted as overrun O. The next point, estimation of the labor time. Labor cost is estimated by the finding the tool time for various operations for the machine work. The first time is the setup time. It is the time required for setting, fixing and arranging the tools, machine and the equipment. It is denoted as T suffix SP. The second, handling time. So time required per job for the activity like starting and stopping the machine, job lifting and the fixing it into the chuck or the fixture, adjusting the tool, etc. is called the handling time, and the handling time denoted as T suffix H. Third is the machining time. It is also called the operation time. It is the time required for actual machining. It is the time for machining operations to convert the material into a product. It is denoted as T suffix M. Next one is the miscellaneous allowances. Workers are in need of the some time for the natural calls, smoking, washing of hands, etc. is considered as 5% of the total machine time. It is denoted as T suffix A. Time required for the replacing the tool or cutter, tool sharpening is to be estimated in the miscellaneous allowances. Organizational time. During the machine certain obstructions and the restrictions are arising for the removal of the same arrangement are to be made. The time required for the same is called organizational time. The time lapse to start the machine at the beginning of the shift is an example of the organizational time. It is denoted as T suffix O. Next one is the service time. As per the preventive maintenance schedule, the preventive maintenance work is carried out to keep good condition of the machine. The time required for adjusting the changed adjustment, oiling, greasing, then the repairing of the machine part and the replacement of some part is called the service time. It is denoted as T suffix S. Next one is the tear down time. While it becomes necessary to have new machine setup, the setup existing on the machine is removed. Time required to remove the previous setup for the removing the chuck, fixture and tool is called the tear down time. These all types of time are necessary for the some operation on the machine. The summation of the setup time, handling time, the machine time, the miscellaneous time, organizational time, and the service time is called standard time. Is called standard time, and the total time we will calculate it as total time is equal to standard time plus the tear down time divided n, where n is equal to the number of work piece. Thank you. Today, day 1 off.